Okay, guys, today we will talk about solving problems with Newton's law, including again and again we will talk about free body diagrams. If you recall, we have already taken vectors in one dimension, adding and subtracting vectors in one dimension, which was either vectors are on x-axis or on y-axis. And in general, we used to say if the vectors are on the x-axis, we say the vector to the right is positive, the vector to the left is negative. And if the vectors are on the y-axis, we will say up is positive, down is negative, and that's how we used to add up the vectors very easily. But if you see here, again now we are reviewing the two-dimension vectors. So if you see here, we have two forces, and when I say forces, it is an example about vectors because force is a vector, right? So we have two forces acting on the object. One is to the right, which is on the x-axis, 100 Newton, and the other is up on the y-axis, which is another 100 Newton. So we don't have a simple one-dimensional motion, but we don't have a difficult one either. Because, of course, the question will be asking for the resultant force acting on the object. The resultant force acting on the object. That is under the effect of those two forces, FA and FB. Now, some students will just say, okay, 100 plus 100, it is 200. It's not as simple as that because they are not on the same direction. One is on the x-axis, one on the y-axis. So this is, you remember the head to tail rule. This is the beginning of the first vector. This is the end of the first vector. From the end of the first vector, we sketch the second vector. Again, this is the start or the beginning of the first vector. This is the end. Then from the end of the first vector, we draw the other vector. And the resultant vector will be from the starting point till the end point of those vectors. So it's from the beginning of the first vector till the end of the second vector. And because the angle between them is a simple 90 degrees, you see this is FA, this is FB. So originally the angle between them is 90 degrees. So if we have simple triangles, if we have simple right triangle, what is the value of the hypotenuse of this triangle? It is Pythagoras theorem. Of course, here he's saying that the resultant force is equal the addition of FA vector plus FB vector. And we know that as magnitude, it will be the square root of FA square plus FB square. Okay? And that is how we find the resultant force. Okay. So that is the simple one. Now, which is one is simply on the x, the other is simply on the y, and the angle between them is 90. So we use just simply Pythagoras theorem. Again, if you see, I am not using anything. I am not talking about Newton's second law of motion. I am simply just explaining vectors again. So it is like a revision for vectors. Because if you don't understand vectors, you will not be able to keep going with this chapter. So I would like that you really take a serious time and understand vectors if you don't. Now, we are in front of example, and if you see also the example is just simply saying adding force vectors. So again, we are in front of more than one force, and each force, of course, is a vector quantity, and we want the resultant force. You see the question, calculate the sum of two forces. It means we need the sum of the two forces or the resultant of the two forces or the net force. that is exerted on the boat by workers A and B in this graph. So there is a boat here, and there are two workers, worker A, worker B. This is the worker A, and this worker A is pulling the boat with a force of 40 Newton, and worker B with the orange hat, he's pulling the boat with force B, 30 Newton, and the direction where the worker A is pulling is 45 degrees with respect to the x-axis, counterclockwise, while worker B is pulling the boat with an angle of 37, but if you see, it's clockwise with respect to the positive x-axis. Now, just simple problem, and we want F net of the force acting on the boat. Okay, so if you recall, we simply, let me try to pull out a Word document, and I will simply explain as if I will be on the board in front of you guys, trying to write down on the board, so you can bear with me here. Okay, and I will sketch on the draw, and I will choose the, okay, and here, okay. So for simple two forces, we have, so what do we have here? We have FA and we have FB. FA has a corresponding angle F theta A, and FB has theta B. Go back to the figure. So what is theta A? It is a simple 45 degrees. But what is theta B? If you remember, we can say it's 360 minus 37. And let me calculate that. You remember the thing that we are following, that we need the angle counterclockwise with respect to the positive x-axis. And we know the 37, but this is not the angle that we are looking for. If you remember, we are looking for this angle. Let me draw it here. Oh, it will not draw here. Let me just, let me try to figure out how to draw it. Okay. Here, I can use this one. Good. See, guys, it's never too late to learn anything, even if you are above 40. Okay, we want this angle. All right. So this is the angle that we are looking for, which is, if you can help me, it is 360 minus 37. So it's 325. 325. So we have the values of FA, FB, and we should know the values. How much we said? 3. Okay, good. So if we use these angles, this is 45, this is 40, this is 30. Okay, good. So to find F net, I am reminding you, we have done that already, but this is just to remind you. What is F net for any vector, any two vectors? Fx squared plus Fy squared, and what will be the direction? I think these things you all have it in your notes. Tan inverse of theta. Sorry, I have to delete that. 1 minute. Okay, it's not tan inverse of theta. Okay, back to the pen. Tan inverse of Fy divided by Fx. So our main problem becomes to figure out what is F sub x and what F sub y. If you recall, it is F1x plus f1, sorry, f2x, and this is f1y. Do you remember? f2y. And since we choose the proper angles, which are counterclockwise with respect to the positive x-axis, I can simply say it is, and blindly, theta A, basically it is A, okay, plus FB cosine theta B, great. And the same thing will apply here, it is FA sine theta A plus FB sine theta B. You plug in the numbers for thetas, for the F, you get the numbers, you find the F net, and that's it. It's as simple as that. Let me go back to the problem. The book, of course, doesn't follow counterclockwise angle with respect to the positive x-axis. I mentioned this before, but I said that it is more safe to do that, okay? But at the end, you will realize that you can literally compare your resultant force and it will be, and then the angle. And that's what you should be concerned about, that there should be the same answer. I think I mentioned this example. Okay, and I am done with that. He just asked simply for the net force and for the net angle, the direction. This example I mentioned while I was going through with you in the class, during class time, that I want you to go through this example, and it's a very important example. This is a hockey puck, and it's sliding on a frictionless ice surface, and they say which one of these, A, B, C, is the correct free body diagram. And I don't want to answer it because I know that some of you now, if I say which one of them, you can see one thing, that all of them has one thing in common, the normal force and the gravitational force. But it's either without anything else, or with a force backward, or with the force forward, or without anything. So they say if an object is moving on a frictionless ice, which one of these three will be the best description for the correct free body diagram? I know that some of you will choose this, some will choose this and they have some reasons, some will choose this and they have some reasons. Luckily, the book has explained everything, so I would advise you that first you try to guess and you have your own reason in your mind, and then read, did you choose the right answer or the wrong one, and why is that? All right, I am almost to finish here. Okay, now next record I will be explaining vectors, not simply on the y and x axis only like we have done before, but now we have some kind of vectors with an angle, and that was the reason why we went through the review of vectors, because we will be facing some kind of forces which are acting on the object as with an angle, and also we will have forces along the y-axis and maybe friction, so there will be forces along the x-axis as well. And the thing that I just want to mention, that whenever we have any vector with an angle, the best thing to look at it is to decompose it into its x component and y component. And then we will continue in the problem as two problems, one on the x-axis, one on the y-axis. This is just a brief introduction for this example. Meet with you in the next record. Take care.